Welcome to 2.2, page 2. Hopefully you're through with page 1 on the note page. 23 through 28. Use a graphing calculator to graph the functions f and g in the same viewing window. Zoom out far enough to see the right and left hand behavior. That might not happen by Zoom standard, but there's a good chance it will, so let's just get into it. Y equals, got a mess in here now, clear, negative alpha window fraction. You could just make that 1 divided by 3. I kind of like setting it up the way it looks here. We got parentheses x cubed caret 3. Step out of that, minus 3x plus 2. And y2 is just negative alpha y equals fraction 1 on 3, just x cubed. Oops, try that again. Caret 3. And so I'm going to try it in Zoom standard, and we'll just see. There's that first function. And second function coming. And looks like we've got it, so we'll draw a quick sketch of that. Again, anytime you're asked to do things by graphing calculator, I'm just going to try to get a reasonable sketch of it. So let's see, the blue function looks something like that. It goes down, bottoms out over here. And I guess I can call that one F. And then G just looks more like this, and it runs inside over here. So there's G. And so we've got it. Zoom out far enough to see the right hand and left hand behavior. Clearly looks like F and G are both going to rise to the left and both fall to the right. Do the graphs of F and G have the same right and left hand behavior? Yes. Both rise to. Little preposition there, but important one here. Don't want to have you say from. Don't want to say it's rising from the left. It rises to the left, and both fall to the right. It's just kind of like opening up barn doors here. What's happening as we move to the right, what's happening as we move to the left with the graph. Okay, now I suspect we know the answer to that for this problem, but let's go ahead. Y equals, clear these guys. We got 3x to the caret 4 minus 6x squared and just 3x caret 4. Double check on those. Those look good, and let's try that in Zoom standard. Interesting little upside down McDonald's arch kind of thing there, and sort of a parabola looking thing. So our sketch could look something like this. There's F. Looks the same on the other side. In fact, we could make a pretty good argument. Maybe I'll make the second one dotted, since I don't have blue and red pens with me. So this one is G, and yes. Oh, I can't say C, number 24. Both rise to the left and right. And that's what our end model behavior is. That's our left hand behavior, right hand behavior. And finally, y equals, clear, negative parentheses x caret 4 minus 6x squared minus x. Hope you're double checking when you enter these. More mistakes are made just entering these things in your calculator than are actually made any other way on these types of problems. So here we've got x to the 4th. We'll try zoom standard again, just graph. Interesting little first function. First function looks like down here it kind of, I want to start here and to the right it goes up, comes over the axis, goes down, comes up, stays under the axis, goes down, and the other graph up and up. First graph is F, the top graph is G. Let's go F rises, or nope, F falls to the left and right, but G rises to the left and right. So just pretty much straightforward calculator study. You might have to zoom out, but I suspect zoom standard might get the job done for you on 23 through 25. And again, I also believe there's a very good chance that you can answer the yes, no, and the explanations of this, and that is ideal, but I still want to see those graphs. All right, applying the lead coefficient test. Let me get something straightened out here. The lead coefficient test to describe the right and left hand behavior. I'm going to go through all of our tests here. I'm going to rewrite this first as negative x to the 6th plus 1. I prefer it. And I'm going to do my little hieroglyphics here. This graph goes through 1, but eventually wants to look like a negative even. Negative even, like a parabola would be going up, but this parabola would be going down. Even is going to be the same. So eventually wants to look like that. That is a representation of our end model behavior right there. It's all based on this term. So this falls left and right. Falls to the left and right. Whereas this graph wants to go through 0, because there's a plus 0 here, wants to go through there like a positive line, but eventually is going to give way to that, a positive cubic. So this one is going to rise to the right and fall to the left. Okay, 34. Our first term here would be 3/4 x to the 7th, and that is the dominant term eventually. Hey, this thing's going to wiggle around a while. It's going to start out looking like a parabola, try to look like a positive cubic, then a negative to the 5th, but eventually it's going to look like a positive to the 7th. And positive to the 7ths look like that. So this rises to the right and falls to the left, and we should need no calculator to do that. This first term would be negative 7/8 s to the 3rd. It's an upside down odd, therefore wants to eventually look like that. It'll wiggle around for a while, but eventually it's going to look like this. So it's going to rise to the left as it falls to the right. Okay, so hopefully we got that. Important concept for us, not the most complicated, but let's make certain that we're 100% on board understanding that one.